What is AI? Artificial intelligence, AI, is technology that enables computers and machines to simulate human learning, comprehension, problem-solving, decision-making, creativity, and autonomy. Applications and devices equipped with AI can see and identify objects. They can understand and respond to human language. They can learn from new information and experience. They can make detailed recommendations to users and experts. They can act independently, replacing the need for human intelligence or intervention, a classic example being a self-driving car. But in 2024, most AI researchers, practitioners, and most AI-related headlines are focused on breakthroughs in generative AI, Gen AI, a technology that can create original text, images, video, and other content. To fully understand generative AI, it's important to first understand the technologies on which generative AI tools are built: machine learning, ML, and deep learning. Machine learning. A simple way to think about AI is as a series of nested or derivative concepts that have emerged over more than 70 years. Diagram comparing different types of machine learning concepts as nested boxes in bluish hues. How artificial intelligence, machine learning, deep learning, and generative AI are related. Directly underneath AI, we have machine learning, which involves creating models by training an algorithm to make predictions or decisions based on data. It encompasses a broad range of techniques that enable computers to learn from and make inferences based on data without being explicitly programmed for specific tasks. There are many types of machine learning techniques or algorithms, including linear regression, logistic regression, decision trees, random forest, support vector machines, SVMs, k-nearest neighbor, KNN, clustering, and more. Each of these approaches is suited to different kinds of problems and data. But one of the most popular types of machine learning algorithm is called a neural network, or artificial neural network. Neural networks are modeled after the human brain structure and function. A neural network consists of interconnected layers of nodes, analogous to neurons, that work together to process and analyze complex data. Neural networks are well suited to tasks that involve identifying complex patterns and relationships in large amounts of data. The simplest form of machine learning is called supervised learning, which involves the use of labeled datasets to train algorithms to classify data or predict outcomes accurately. In supervised learning, humans pair each training example with an output label. The goal is for the model to learn the mapping between inputs and outputs in the training data, so it can predict the labels of new, unseen data. Deep learning. Deep learning is a subset of machine learning that uses multilayered neural networks, called deep neural networks, that more closely simulate the complex decision-making power of the human brain. Deep neural networks include an input layer, at least 3 but usually hundreds of hidden layers, and an output layer, unlike neural networks used in classic machine learning models, which usually have only 1 or 2 hidden layers. These multiple layers enable unsupervised learning. They can automate the extraction of features from large, unlabeled and unstructured datasets, and make their own predictions about what the data represents. Because deep learning doesn't require human intervention, it enables machine learning at a tremendous scale. It is well suited to natural language processing, NLP, computer vision, and other tasks that involve the fast, accurate identification of complex patterns and relationships in large amounts of data. Some form of deep learning powers most of the artificial intelligence, AI, applications in our lives today.